There seems to be two schools of thought to fixing problems on car engines. One is you just swap parts over randomly until you just stumble upon the problem and you fix it. And the other is to take a systematic approach to diagnosis and work out what the fault is. So we get asked a lot of questions about people tuning cars, having them remapped and then experiencing problems afterwards. We're going to look at how to avoid those in the first place, and more importantly, how to diagnose those faults and problems. And we're going to look at mechanical issues, electrical issues and fuel problems, and the best ways of drilling down to find exactly what the source of that problem is. Hello, I'm Wayne from TorqueCars. We get a lot of questions from people that have problems after they've tuned a car, particularly after it's been remapped. Now, did the remap cause the problem? In most cases, it didn't. Most remappers out there know what they're doing, and when they set a car up, it's getting the optimum performance from your engine. But we do see a lot of problems with flat spots, misfiring, and other little glitches that happen. So why do these happen? How can we diagnose the faults? And how can we prevent them from arising in the first place? So think of firstly an F1 engine. It's running probably at the peak of efficiency. The manufacturing tolerances are so fine, the engine has to be pre-warmed so all of the metal components can fully expand in order for the engine to work. Otherwise, in its cool state, everything is seized. So an F1 engine is not a great proposition for a road car. You don't want to have to run it through some sort of preheating regimen before you even turn the starter key. So manufacturers, they build in a really wide margin of error in the manufacturing tolerances of the parts and in the map that they put into the car so it can cope with bad fuel, different weather conditions, different driving conditions. And manufacturers know that people don't look after their cars generally. Most people don't keep up with the servicing schedules, the air filters get clogged, the quality of the oil is degraded as it has become very sludgy over time. So all of that is really built into this safety margin. Now when you tune a car, you are reducing that safety margin, so you're extracting the maximum amount of performance. So the deal there is, if you want more performance from your engine, you are prepared to do more maintenance. You will change the oil more frequently. You will keep all of the components in top condition. And that really is where the problem is. The map has highlighted a weakness in the car. Sometimes it's just a hose that has become split with the increased pressure that the turbo is producing in the engine, and you've got a loss of air pressure in that. Quite a simple one. That's not the cause. The map has merely run the turbo at its maximum capacity, and that weakness that was pre-existing in your car has shown up by virtue of that split pipe. So faults tend to crop up in three different areas: mechanical faults, fuel faults, and electrical faults. And the way you diagnose them, it's a slightly different approach for each of them. But the questions you need to ask yourself, and if a mechanic is talking to you about your car, he will want to know where the problem is happening. Is it when the engine is warming up? Is it on a cold engine? Is it at a certain point in the RPM range where you're experiencing the problem or the misfire or the flat spots? All those questions can help to pinpoint what's going on, because an engine operates differently. When it's warming up, it tends to put more fuel in. When an engine is already warm, it tends to trim back the fuel because it doesn't need as much to get the engine warm, and it starts to run in a more efficient mode. And when an engine is under load, again, all of the parameters of the timing and the fueling are all adjusted to give you the maximum performance in that situation. So just knowing where the problem is in the RPM range and under what conditions can really help to diagnose what the fault is. So getting the car on some sort of test equipment, you may well find it's throwing up error codes, and these are invaluable. It will tell you if some sensor is giving values that are outside of the expected norm. Now that could indicate a faulty sensor, or it could indicate a fault in the area of the car that that sensor is covering. A lot of the problems actually come from the injectors that become worn. So instead of giving a really nice spray pattern, you get a jet of fuel that just dribbles into the engine, and you don't get a very good burn on that. Now the standard manufacturer setup can cope with that. You'll get lower performance, but it'll quite happily run. But when the car is tuned, that's become a big problem. You're going to have a problem with the fuel not burning correctly, and the car is going to try and work out why it's not burning correctly. Should it dump less fuel in? Does it need more air? Does it need to adjust the timing? And while it's doing that, you'll get all sorts of flat spots and problems. So the car is actually doing its best with what it's given, but if you've given it bad injectors and a bad supply of fuel, it's really unable to do what it wants to do. Sometimes just switching the grade of fuel to a higher octane fuel is enough. If you're experiencing knock, for example, you may find the engine trimming things back and retarding the ignition timing to avoid that situation. But if you have a more knock resistant fuel in your car, that can give you a wider margin of error. We've actually heard of people that have pretty much solved flat spots and running issues just by using a higher grade of fuel. And in a lot of those cases, they found out that when the car was mapped, it was originally set up for high octane fuel. So as soon as they've put the lower octane fuel in, they've moved right outside of what the car was set up for. And that's why they're experiencing a problem with it. So with electrical problems, you need to really check all of the connections. It's a good idea just to remove and refit all of the plugs. If you can get a multimeter on there, you can actually see what the voltages are doing at different times, and that can indicate whether perhaps a sensor or a relay or a wire is not working as it should do. Check also the distributor cap, the ignition coils. They're a common point of failure in a lot of cars, and just swapping them around can actually change the problem. So for example, you've got a 4-cylinder engine, it's misfiring, the error code is showing there's a problem on cylinder 1. Now if you move the coil pack to cylinder 3 and swap them over, and you start the car up and you get an error code, if that error code has moved to cylinder 3, you know the problem was the coil pack. So straight away, just swapping the coil pack for a decent one, and it makes sense to change all of the coil packs at the same time. It'll solve your problem and you'll be fine. As leads get older, and with the vibration and flexing, the conductivity inside them breaks down. You don't get the circuit forming as it should do. Sometimes they need to warm up before you get the contact. Just removing and refitting all of the leads is sometimes enough just to give you a good contact. Earth problems can also crop up where the car's not correctly earthed, and that can create really weird intermittent problems and faults. And in some cases it's just the battery terminal has become loose, or the connection to the car has become loose. So it works most of the time, but as soon as you go over a bump or meet a certain set of conditions, the circuit breaks down and you start to have problems. So with mechanical faults, you're into the realms of really getting a mechanic involved. You want to check the clearances on the valves. If the valves aren't opening correctly, you won't get as much air into the engine, and that can affect the running of the engine. And it's quite a common thing. Very few people actually check the valve clearances, and when you take a car in for a basic service and an oil change, that's insufficient. They're not checking the valve clearances. And it's a good idea to get a compression test done on the engine, and that measures the amount of compression that happens inside each cylinder. Ideally you want them all to match, but in the real world that doesn't happen. They're always within a little bit of each other. But if a cylinder was leaking badly, that would indicate the source of a mechanical problem, and you may well need to get the engine stripped down and rebuild the components causing the problem, which sometimes it's just the valves in the head, sometimes it's the piston rings that have degraded and causing a problem, or even cracks in the cylinder wall can really affect the compression of the engine. And if it's not even, the ECU is going to struggle to make sure everything runs smoothly, and it's going to back off the power overall to try and protect the engine from itself. It's also worth checking the cooling system. If you start to see oil in the cooling system or coolant in the oil system, you've got a problem. Lifting off the cover on the engine where the oil goes in, if you notice a creamy white mayonnaise-like substance, that would indicate that water has become mixed with the oil, and you could well have some kind of head gasket problem that's causing the issue there. With fuel issues, you may well find that the car is running lean, and that's often not enough fuel getting into the engine, or the spray pattern and the atomization of the fuel isn't happening correctly, so it's not burning properly. So check the injectors. You can get them professionally checked and cleaned and swap them out. Again, if your car is giving you some sort of error code relating to the fuel on one cylinder, you can adjust the injectors over and see if the fault moves to another cylinder. Check all of the pipe work going from the fuel pump to the injectors as well for leaks. If you can smell petrol or diesel around the engine bay, that's often a sign that there's a leak somewhere, and a leak will not necessarily stop the engine from running, but under pressure and load it can diminish the supply of fuel to the injectors, and you can experience all sorts of flat spots and running problems. So when you've tuned an engine, just remember to keep it in good condition. The best way of tuning an engine and getting it mapped is getting it set up on a rolling road so they can actually look at what's happening in your engine live. And most good tuners will take a diagnostic look at the car before they even start mapping it, and they will highlight the problems that crop up. And another issue that sometimes comes to light is the clutch starts to slip. Now, the map hasn't broken the clutch. The clutch has just degraded to a point where the increase in power has pushed it over that threshold or that tolerance. So before you get your car tuned or mapped, just make sure everything is running in perfect condition, and you'll avoid all of these problems, and people won't be emailing us if they've watched this video to discuss problems that have happened after a map. By all means, talk to the company that did the map or did the tuning, but don't blame them. It is very rarely their fault. In 99% of cases, it's a pre-existing fault on the car that has just come to light after it has been mapped. If you found this video useful, please subscribe to our channel. We've got lots more informative videos and tutorials coming up that go into more detail on all the aspects of tuning your car, getting the most performance and keeping your car in good working order. So be sure to subscribe, hit that bell, and you'll be notified whenever we release a new video. And thanks for watching. We'll see you in the next video.